Okay, we're picking back up on question 25 on page 9. You guys should watch this too. You have to find the resultant speed. If you are forced to find the resultant, you have only one real option. That option is combine the x component and the y component to get the resultant. For the acceleration, it's easy. Nothing with 9.81 down gives you 9.81 down. For the VI, it's easy for these problems. 15 to the right and nothing gives you 15 to the right. The displacement and the velocity final are actually different because there's no nothing in there to just ignore. For the displacement, you would have, actually if you sketch this out, the displacement in the x. Here's the cliff. Here's the trajectory. The displacement in the x is from here to here. That's this. The displacement in the y is from here to here. That's this. Now if you put arrowheads on them, the resultant displacement actually would be circle the start, x the finish. Here's the start, here's the finish. This would actually be the resultant displacement, which you could then do with, this is 14, this is 25, this is your resultant, if you're trying to find, 14 squared plus 25 squared equals r squared, solve for r. That would be your resultant displacement. However, resultant displacement is seldom asked. Resultant final speed, however, is often asked as far as the resultants go. And it's the same issue. We'll take this same picture and sketch it again over here. Here's the cliff. Here's the trajectory. And now at this very location, just as it's about to smack the ground, it has both a vertical velocity, a Vy at the end, and a horizontal velocity, a Vx at the end. Your job is to find the resultant. The resultant, in this case, these are currently not drawn head to tail. You could move over the Vy to here, and then you would have circle the start, x the finish. This would be your resultant velocity. Now how would you find that? The same way we found it over here. The resultant velocity squared equals the x velocity squared plus the y velocity squared. Now these are all final velocities, and so our issue now is, do we know both Vf in the x and Vf in the y? Well, we know Vf in the x, but we don't know Vf in the y. And so we need to find Vf in the y in order to answer this question. This is what we mean by pump your feet. So you're going to have to pump your feet over here. First, we're going to use the y column to find Vf in the y. Easiest way to do it, Vf equals Vi plus At. There are other ways. You could use Vf squared equals Vi squared plus 2Ad, but this is quicker and easier. So if you substitute, Vf equals, Vi is 0, plus 9.81 times 1.7. And that will give you a Vf in the y direction of 16 point? Okay, 16.67, so around the 16.7 meters per second. And so that actually is our Vf in the x direction. Now I can actually say 16.7 meters per second. And so now we're ready to actually solve for the resultant final speed. The resultant final speed will then just be these numbers we can actually fill in. This one is 16.7. This one is 15. Put it all together. Vr squared equals 15 squared plus 16.7 squared And so your resultant velocity, you square root the whole thing, and you should get 22 meters per second, roughly speaking. That gives you the resultant final speed. Tough question. That's one of the tougher questions you could possibly see. Finally, the last one. What vertical distance does a car fall between 0.5 and 1 second? So we'll pause. I'll do that one on one last video.